Okay. All right, so we're going to do a tangent line equation. The problem is number 24. So the function we were looking at would be x over e to the 2x. And we were being told x equals 1. And pretty easily, even though they gave us this, if I took that and I put 1 in for x, I get a 1 over e to the 2 times 1, or 1 over e squared, and that's our y. If I did have you find it, you could find it. In the textbook's case, they gave you both x and y. So we have both pieces of the point. We're going to use point-slope form to write our tangent line equations, just like we did back in Unit 2. So I've got the x1 and the y1 now. The only thing I need is the m. And just a quick reminder that we get the m by taking the derivative, and then finding that derivative value, in this case at x equals 1, gives us our slope. And because our function looks the way it does, we are going to have to use quotient rule. And we're going to have to use what we learned about derivatives with e. So, here I go. If I want to take it slow with my quotient rule, my numerator I identify as my f function, so f prime would be 1. Hi, come on in. My g would be e to the 2x. Thank you. And so g prime, what we learned in this unit, when I take the derivative of an e function, I get the exact same e function back. E to the 2x's derivative is e to the 2x, but chain it up. Chain of the derivative of what's in the exponent, so the 2x's derivative is 2. So then I put my quotient rule together. 2x. See, all right, I'm going to do this. I'm realizing now, like, why do we do this? Because it makes it easier. If I do this, g f prime minus f g prime over g squared, then it just is a little easier to pull the pieces. So e to the 2x times 1 minus x e to the 2x times 2 over e to the 2x all squared. Okay. Let's get caught up on that if you're working along with me, or if you're checking your work. So in the process of, if the question is just, hey, write me a derivative, that's a good answer. It's not the prettiest cleaned up answer, but that's okay. We don't necessarily always need that. That derivative works just fine. If you want to clean it up a little bit, you can. We are going to have to do something with this to get a value. My preference for you, so that you continue to practice things that you may have to also do again in the future, would be, let's leave our answer in terms of e when we plug in x equals 1. But since we are also using calculators, like really, you know, if you wanted to then somehow take this to a calculator answer, a decimal answer, I would be okay with it. I don't love it, but it's just part of it. I think, you know, kind of have to be okay with it. So if x is 1, this derivative becomes e squared times 1 minus 1 times e squared times 2, all divided by e squared squared. Every place I had an x, I put a 1 because they told me x was going to be 1. Now, if you throw that all in your calculator, like that. You've got to be really, 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 really careful about the order of operations and grouping things and all those other little pieces, because it's very easy, even with a calculator, to evaluate this incorrectly. Taking a couple little chunks of it, e squared times 1 is e squared. This guy back here minus, that becomes 2e squared. This is e to the 4th. Now, you got to be careful about crossing things off. Right. There's a couple different ways you can approach this. The way I think about this is, if I look at this and I think about e squared as sort of just a thing, like a variable, like an x or whatever, it's an e squared. If I have 1 e squareds minus 2 e squareds, I have negative 1 e squareds left. One of them minus 2, because they're the same expression. They're essentially, in a way, kind of like terms, I guess, is one way you could think about that. E's with the same power, you can do addition and subtraction with. So if I have an e squared and I subtract 2 e squareds, that gives me negative 1 e squared. Another way to think about this is you could look at both of those and say, hey, I can factor out an e squared. And e squared times 1 minus 2 would be e squared times negative 1, or negative 1 e squared. So that's a second version. This is one version of that answer. This is a second version of the answer. A third version of the answer looks like that. And yet a fourth version, if you're like, forget these e's nonsense, I'm going to try to wrap this out of my calculator. If I go 3 decimal places, that's an estimate, okay? Now, messy answer with 1 plugged in. I think we could do at least this. I mean, at least clean up the products. Combining the terms, dividing out an e squared, getting the decimal answer. If you want to try to get the decimal answer from here, you can. Just have to be really, really careful about getting this product, subtracting those products, and then dividing it by a full e to the 4th. Trying to kind of type that all in your handheld calculator, it's usually, we've got issues with typing and things. So if you're not getting this answer, but you had this, you might just kind of see like, okay, let me just embrace a little bit of simplification. And even something that's easier to put in the calculator because it's less pieces can be helpful. Or just, be brave and get it down to something like that. Final answer, ultimately the line, 1 minus 1 over e squared equals negative 1 over e squared times x minus 1. Okay. With, a couple different versions of that particular value could be appropriate. Okay, so nothing new in the process. Take the derivative gives you the slope. We use the original function to write the point. We write the point slope form of the line. All that stuff's the same. Parts that are different, you got a big mess of e's to work with. So that's gonna make probably the derivative steps. You have to think about how you're gonna take the derivative of the e pieces, potentially product rule, quotient rule, chain rule, other things. And when you're then evaluating, sometimes you might get a derivative that is best evaluated and is ultimately a form of E. This is definitely one of the trickier ones in terms of the simplifying. I don't know that the derivative is a big deal. You guys can do quotient rule pretty much backwards and forwards. Hopefully you remembered the two part here. But then simplifying that can be a little intimidating. All right, so things you're going to have to do on that quiz that's coming up. So just writing the derivatives for different scenarios with E, writing a tangent line equation, that's going to be part of it. And at least two other kinds of problems. One's going to be what we're going to work on today, which is essentially taking E and unit 3 and putting some of that stuff together. Not all of it, but some of it. And then the last part will be, well, E with an actual function model, a more real application with an E function and solving problems with those. All right, questions on the tangent line stuff? Okay, so I'm going to stop this for